The last topic we'll discuss today is relative velocity. Okay, so now we're talking about two objects, A and B, and let's say they're both moving. Suppose we have two objects, A and B, which are moving with velocities VA and VB respectively. Okay. So we have, here's A. Let's say A is moving in this direction with this velocity, and then B is moving in this direction with that velocity. Now let's talk about how A, let's say you're A, and you're looking at B, and you're asking, what is the velocity of B relative to me, which is A? So what does B look like compared to how I'm moving, or the way I see B moving? Okay, so let's write this out. From the point of view of A, B looks like it is moving with relative velocity. So the word relative is important here. With relative velocity, let's make it very clear. Velocity of B relative to A. What does B look like relative to A? And this is going to be VB minus A. All right. In other words, A must subtract off its own velocity, which we call VA, to get the relative velocity. So to get the relative velocity of B compared to A. Okay. So another way of thinking of it, maybe you prefer this way as well, is we can also write that the velocity of B is equal to the velocity of A plus the extra amount that B is moving relative to A, B relative to A. Okay, so I can rearrange this and write this as VB relative to A is equal to VB minus VA. You can see these two equations are the same if I solve for VB relative to A. Okay, so if you're having some trouble with this, let's do an example. Okay, let's have a road. And let's say we have some car here, A, and this is moving at 40 miles per hour. And then we have a faster car, B, that's moving at 65 miles per hour. Okay, this is the plus x direction. Then the relative velocity of car B relative to car A is just V relative to A, and that will be the velocity for B, so that's 65 miles per hour in the positive direction, minus the velocity of A, which is 40 miles per hour in the positive direction. And so we end up with 25 miles per hour relative velocity in the plus direction. Okay, hopefully this is clear to you. If you're in the slower car from behind and you're watching car B, then car B appears to be moving 25 miles per hour away from you in the positive x direction. Right? Let's do maybe a more complicated example where we have motion in two different directions. Okay, let's do an example. Let's say a person walks with velocity 1.0 meters per second in the j-hat direction relative to a river raft. Okay, this is a person standing on a river raft, and the raft will be drifting, but the person's also walking with a velocity 1.0 meters per second j-hat relative to a river raft. I'm going to draw everything in a second. Let me just finish writing the problem. The raft is drifting 2.5 meters per second I-hat relative to the riverbank, just the land next to the river. So we have this sort of picture. So this is a bird's eye view. We're looking at it from above, from a drone or something. And then we see this person standing here, but the person is moving. Okay, so this is a bird's eye view. This person is moving horizontally, but in this direction. Okay, with 1 meter per second, j-hat. But the raft itself is moving with speed 2.5 meters per second, and it's going in the I-hat direction. So the question is, what is the speed and direction, or the angle, relative to the riverbank? When I'm talking about the speed and direction of the person, I should clarify that, relative to the riverbank. Okay, we want the speed or the magnitude of the velocity and the direction. Let's say, so this is going to be positive x direction, this is positive y direction. We want to know the angle measured counterclockwise from the plus x direction. Okay, so once you give this a try, and then when the video resumes, we'll go over this